Hey everyone, I'm Richard. In the last video we successfully built our ColorPicker node, with all the 6 visual layers and the ability to perform an animation. Now in video 2, we start building the interface that lets us customize our character. We'll design our first panel for the hair color, and use signals to trigger the color change on the hair sprite of the player. Open the main scene. For our UI we're going to use a canvas layer. This is crucial as it ensures our interface elements are drawn above everything else in the game world. Let's create a new canvas layer and call it Interface. Inside our interface, create a margin container. This is a great starting point for any full-screen UI because it helps us manage safe areas. Go to Layer mode and choose the Full Rect Anchors preset. Full Rect will automatically make this container take up the entire space of its parent node, the canvas layer. Now, open the theme overrides in the inspector, and under Constants, let's give a comfortable 50 pixels of margin on all 4 sides. This keeps our UI content from touching these screen edges. Inside the margin container, create a simple control node, which will act as a blank canvas, allowing us to freely position the UI panels inside the margins we just set. Next, we'll create a VBoxContainer inside our control node and call it Left Container. This container will manage and stack all our UI panels vertically on the left side of the screen. Let's head over to the layout section on the right and give it a custom minimum size of 330 pixels on the x-axis, to ensure it has enough width for our panels. Then, under Layout, change the layout mode to Anchors. This lets the container resize dynamically with the screen, instead of being stuck to the fixed pixel positions. Finally, set the Anchors preset to left-wide so it stretches from top to bottom on the left side. Now, let's focus on the hair color panel. Inside the left container, create a panel container and name it HairColorPanel. And inside that one, we'll place another VBoxContainer, and its first element will be a label. Let's give this label the text hair color. Let's also change its horizontal align to center and set the font size to 25. To make sure our UI looks good, let's quickly set a custom font for our entire project. Open your project settings and scroll down to the Themes section. Then click on Custom Font and select the one provided inside the Fonts folder in Assets. You will be warned that in order for these changes to take effect, you'll need to restart the editor. Let's click on Save and Restart so we can have our new font changes applied. Now we can see our hair color label immediately reflects that new font, which matches better our overall pixel art look. If we head over to the labels font under Theme Overrides, we can see our custom font file is the one applied. That will be the default behavior for the rest of the labels we'll create in this project. Finally, let's add the core functionality element, a ColorPicker node, right underneath the label inside the VBox container. We can see we got a very complex color picker with lots of options, but let's keep it simple and let's get rid of most of them so we end up with the core color selection functionality. Let's uncheck Edit Alpha, Edit Intensity, and also everything under the customization section. Now for the styling. Click on the hair color panel. On the right, scroll to Styles inside Theme Overrides and create a new StyleBoxFlat. We'll use this to customize the panel's appearance. For the background, choose a dark gray color. I'll be using a color with the value of 28, 28, 28. We also want a nice outline, so set the border width to 5 pixels on all 4 sides. And set the border color to black. Finally, in the content margins, add 15 pixels to all sides. This creates padding inside the panel so our color picker and label don't sit right against the edge of it. We'll reuse this style for other panels, so right-click on the style we just created and click on Save As. Let's create a styles folder inside our Assets folder and name it Panel Style. Now, save Panel Style inside the Styles folder. One last detail for the layout. Select the inner VBox container and scroll to the constants inside Theme Overrides. Then set the separation to 15. This adds some breathing room between our label and the color picker as well. Our panel is now fully styled and laid out, so let's make it a reusable scene. Head over to the File System panel and create a new folder inside Main, called Interface. And inside that one, a Hair Color Panel folder. Now, save our HairColorPanel as a scene right there. and then let's open it so we have that layout in its own view. Make sure to have the HairColorPanel node selected, and on the inspector, let's create a new script named HairColorPanel. Once created, it will open automatically, so let's start by giving it the HairColorPanel class name. And then, let's create a signal called Changed, which will be emitted whenever the user selects a new color. So let's also specify that we will be sending the selected color to whichever function is connected. Next, we need a reference to the ColorPicker node. Let's create it by using the onReady keyword and the $sign to specify the exact node path to the ColorPicker as we have it in our scene. Continue by connecting the ColorPicker's built-in signal. We do this in the ready function. Now, whenever the color changes, our new private function, onColorChanged, will run. Let's define this function now. We want it to take the new color that was sent from the ColorPicker, and then simply emit our custom change signal passing that same color over, so functions connected to this signal will also be aware of that new selected color. Let's save and run the project. If we now select any new color on a newly created picker, nothing happens. That's because even though we are capturing the color change and emitting that color through our custom change signal, no function is yet connected to it. So let's head over to the main scene. Then be sure to have the main node selected and create a script for it called main. Let's define its class as main, since from here is where we want to connect to the HairColorPanel and change the player's hair color once the color changes, we'll need references to both nodes. So let's again use the same method as before with the onReady keyword and the $sign path node to reference them. For the HairColorPanel, the node path is quite long and complex, so we can just start by typing HairColorPanel after the $sign, and Godot should be able to suggest us the correct path for it. Choose the one ending in HairColorPanel. Now, inside the ready function, we will connect to our HairColorPanel's custom signal that we created before, and define the onHairColorChange function that will be the one being called when the signal is emitted. It's inside this function where we want to receive the new color and change the player's hair sprite, but we don't have access to that sprite from here. So let's write fast for now so the editor doesn't complain to us because we're having an empty function. And let's open our player script. Here we want to create a public function that can be accessible from any other script having a reference to the player. So we declare the function without the underscore as the first character. This function will receive a color, and assign that color to change the modulate property of our hair sprite. This is a key step. When you assign a color to the modulate property, the hair sprite will tint its current texture with that color. Since our hair sprite is drawn using white and shades of gray, the modulation will apply the color perfectly. If your sprite's texture were to have a strong color, modulation will produce unexpected results. Now that we have a way to changing the hair sprite's color, let's jump back into the main script and complete our connection logic. Replace the pass inside onHairColorChange with the call to our player's newly created function to change the hair sprite color, and pass the color we receive from the HairColorPanel. Now it's time to hit play. If we now select a new color in our color picker, we can see our character correctly reflecting that change in the hair sprite. This confirms that our system of signals and connections is working perfectly. We have successfully built and integrated our first fully functional customization panel. In video 3, we're going to expand our character creator by tackling a new challenge, building the skin tone panel, which will allow us to change the player's skin tone by selecting from a specific set of color swatches instead of a color picker. Thanks for watching, and see you in the next one.